Alright, back again with the review for the test coming up. And in this case, we're going to solve equations involving absolute values. Now, the trick here for absolute values, we need to isolate the absolute value. And one of the tricks I've been doing for that is I've been drawing a box around the absolute value. So the question is that absolute value isolated? Is it by itself on the same side of that equation? In this particular case, yes it is, because there are no constants, there are no coefficients. So since it is by itself, we're able to go ahead and split the problem into the two directions, positive and negative, because absolute value again is the distance from zero. And when we're doing distance from zero, there are two directions that we can go, negative and positive. So in this case, we have the absolute value of something is 3. Well, the number that is 3 away from 0 in a negative direction would be negative 3, but the number that's 3 away from 0 in the positive direction would be positive 3. In this case, we're trying to find x over 7 equaling negative 3 and x over 7 equaling positive 3. So if we do this, now we just solve the equation, and since it's x divided by 7, the opposite of division is multiplication, so we multiply by 7 on both sides. So by multiplying the 7, it cancels out the dividing by 7. So we're left with x equaling negative 21 and x equaling positive 21. And that's it for that problem. So if it already is isolated, it makes for a very quick and easy process. Now for a slightly more involved process. So when I look at this particular problem, that absolute value, the 5m minus 5, that's not isolated because we have the 2 minus and the 5 multiplied to that absolute value. So what that tells us is we have to get that box by itself. And the way we do that is the same way we would solve an equation. So I don't see distributive property because as much as you want to think this is, it's not. Don't see like terms because the 5 is attached to the box. That's 5 times that. We can't just combine the 2 and the 5. There's not a variable on both sides. So we have to get rid of a constant. And the constant in this case is the 2. And since that's a positive 2, we're going to minus 2 on both sides because of those properties of equality. It's about maintaining balance. So we now have negative 5 times the absolute value equals, and negative 73 minus 2 is negative 75. Next, since that's negative 5 times the absolute value, cancel that out, we have to divide by negative 5. So that those cancel. And we are left with the absolute value of 5m minus 5 equals negative 75 divided by negative 5 is 15. Now, the same way that we isolated the absolute value on example 5, how it was already isolated, we've now isolated the absolute value on example 6. So this is where we get to split it into those two directions. We have the negative and the positive. So the negative in this case is 5m minus 5 equals the negative of our answer, which is negative 15, and the positive, which would be the same 5m minus 5, equals positive 15. Now, just as a heads up, and just to make sure you notice, once we have split the absolute values into the negative and positive directions, notice the absolute value symbols have gone away. Don't keep them. Otherwise, that's just going to create confusion. So, at this point, this is a two-step equation. We have the constant of minus 5. We need to add 5. So 5m equals negative 10. And coming over here, it's still the exact same. We're adding 5 both sides. That's going to equal 20. So finally, to get rid of the coefficient, to eliminate that, we're going to divide by 5 everywhere. Ooh, that was so bad. So m equals negative 2, and m equals 20 divided by 5. That is a very, very ugly 5. But 20 divided by 5 is, wherever my mouse just disappeared to, is 4. So here's the third example video. Hopefully it helps, and good luck preparing for your test.